Everything you believe about motion is wrong. Right now, you are not sitting still, you are falling. At 630 kilometers per second, the Milky Way is plunging through space, dragged toward the Shapley Supercluster. But here's the part. Your instincts never prepared you for that speed doesn't make sense. The pull ahead isn't strong enough. Something else is altering our trajectory, not a hidden force, not a mysterious field, a void. The local void, an enormous region of near nothingness beside us, creates a gravitational imbalance so deep that it behaves like a push, tilting the flow of space itself. And to understand how a void can redirect an entire galaxy, we first need to understand where we are in the cosmic map. Speed without a map is meaningless. To understand why we are moving this fast, we must first understand where we are. If you were to zoom out from Earth past the solar system and beyond the Milky Way, you would see that our galaxy is not floating in isolation. We are one member of the local group, a small cluster of galaxies bound together by gravity. But zoom out further, and the true structure reveals itself. This is Laniakea Hawaiian for immeasurable heaven. It is our home supercluster, a colossal structure spanning 520 million light-years and containing over 100,000 galaxies. But Laniakea is not just a static web of stars. It is a gravitational watershed. Just as rain falling on a mountain range flows into tributaries and rivers, every galaxy in this region is sliding down invisible slopes of gravity. We are caught in a cosmic riptide, flowing alongside thousands of other galaxies toward a dense gravitational center known as the Great Attractor. However, even the Great Attractor is just a bend in the river. The true monster lies further out the Shapley Supercluster, the most massive concentration of matter in our local universe. It is the anchor pulling the entire web towards it. On this scale, the universe looks like a synchronized dance, a majestic flow of matter obediently following the laws of gravity. The map looks calm, but the numbers don't, and that's where the mystery begins. For decades, we believed the universe was democratic. The cosmological principle taught us that on large scales, matter is distributed evenly, a smooth, uniform sea of galaxies, extending in all directions. If this were true, our movement through space should be predictable, governed solely by the Hubble flow, the steady, uniform expansion of the universe since the Big Bang. Every galaxy should be drifting apart from every other galaxy at a rate proportional to distance. But in 1987, a team of astronomers led by R. Brent Tully discovered that the Milky Way was breaking the rules. We were not just drifting with the cosmic current, we were sprinting across it. When astronomers subtracted the expansion of the universe from the motion of the local group, they found a residual vector, a peculiar velocity. Think of the universe as a vast flowing river. The river itself is the Hubble flow, carrying everything downstream. But a peculiar velocity is like a swimmer fighting the current, striking out in a specific direction. Our swimmer, the Milky Way, is stroking fiercely at 630 kilometers per second toward the constellation Centaurus. In the courtroom of physics, velocity is evidence. An object does not accelerate to 2 million kilometers per hour. Without a cause, a force is required. To generate this kind of kinetic energy for a galaxy containing 1 trillion solar masses, the gravitational engine must be colossal. For years, the prime suspect was the Great Attractor, a dense concentration of galaxies visible in our forward trajectory. But the math didn't balance. The mass of the Great Attractor was insufficient to explain the sheer violence of our speed. It was as if we were seeing the bullet, but missing the gun. This discrepancy forced astronomers to re-examine the vector. If the visible mass in front of us wasn't strong enough to pull us this fast, then the equation was missing a variable. We weren't just running toward something, we were running away from something. If something is pulling us, something else must be failing to pull. To find the missing variable, we had to look behind us. But for a long time we couldn't. The direction directly opposite our motion lies behind the zone of avoidance, a thick band of dust and stars within our own Milky Way that blocks optical telescopes. It is a cosmic blind spot, hiding 20% of the sky from our view. It wasn't until the development of radio and infrared astronomy technologies capable of piercing through the galactic dust that we could map the terrain in our rearview mirror. What we found there was not a monster, but a deficit. We call it the local void. Contrary to popular imagination, it is not a hole in reality or a region of absolute nothingness. In astrophysics, a void is a region of extreme underdensity. While the average cosmos contains a sparse scattering of matter, the local void is a barren desert stretching between 150 and 230 million light-years across. It contains only 30% of the matter found in typical regions of the universe. If the universe is a sprawling metropolis of galaxy clusters and filaments, the local void is a vast empty park in the center of the city. There are a few isolated dwarf galaxies drifting through it like lonely ships on a dark ocean. But for the most part, it is silent. This structure is massive. It dominates a significant portion of our immediate cosmic neighborhood. For decades, it was treated as a curiosity, a blank space on the map. But in the forensic analysis of our peculiar velocity, this emptiness is not neutral. It is active. We exist on the local sheet. A flattened wall of galaxies bordering this abyss. We are perched precariously on the edge of the cliff. And while the Great Attractor and the Shapley Supercluster loom in the distance pulling us forward, the local void sits directly behind us, vast and hollow. Its discovery changed the equation of our motion, but it deepened the mystery. Mass creates gravity. Gravity creates pull. How can a region defined by the lack of mass, by the absence of gravity, exert a force strong enough to shove our galaxy across the universe? Knowing where the void is tells us nothing about why it moves us. This brings us to the central paradox of our journey. In classical physics, gravity is a force of attraction. Mass pulls mass. A star pulls a planet. A black hole pulls light. By definition, empty space contains no mass and therefore possesses no gravity. It cannot pull, and it certainly cannot push. So if the local void is just a region of missing matter, how can it generate the velocity vector that is driving our galaxy at such breakneck speeds? The answer lies in a counterintuitive concept known as the dipole repeller. To understand it, we must shift our perspective from simple forces to the complex geometry of gravitational fields. Imagine the universe as a stretched rubber sheet. A massive object, like the Shapley Supercluster, sits heavy on the sheet, creating a deep well, a basin of attraction. Matter naturally flows down into this well, but the local void represents the opposite. Because it lacks the mass of the average universe, it doesn't weigh the sheet down. Relative to the dense regions surrounding it, the void stands out as a peak, a gravitational hill. In 2017, astronomer Yehuda Hoffman and his team mapped the flow lines of the local universe and confirmed this dipole structure. We are caught in a gravitational slope. The Shapley Supercluster is the valley in front of us. The local void is the mountain behind us. We are not just falling into the well, we are sliding off the hill. This creates what physicists call effective repulsion. It is not that the void exerts an active force like a rocket engine or a magnetic field. Instead, the void represents a deficit of pull. In a universe where every object is constantly tugging on every other object, a region that doesn't tug acts like a repulsor. Think of it like a helium balloon floating inside a car. When the driver hits the accelerator, the passengers are pressed back into their seats by inertia. But the balloon does something strange. It moves forward. It defies intuition. Why? Because the air in the car is heavier than the helium. The acceleration forces the dense air to the back of the car, displacing the lighter balloon and squeezing it forward. The local void is the helium balloon. The surrounding universe is the dense air. The gravitational grip of the cosmic web is tightening around the void, pulling the dense clusters together and squeezing the underdense regions outward. The Milky Way sits at the interface of this pressure. We are being squeezed away from the emptiness driven by the crushing weight of the universe collapsing around a hole. This is the engine of emptiness, a passive absence that dictates an active path. But a void is never born empty. Something carved it. To understand why the void exists, we must look far deeper into time than we look into space. We must return to the first moments of the universe, long before the first star ignited, to find the architects of this emptiness. The map of our galaxy's motion was drawn by sound. In the first 380,000 years after the Big Bang, the universe was not the cold vacuum we see today. It was a hot, dense soup of plasma, a blinding fog of protons, electrons, and light. And it was loud. Quantum fluctuations from the moment of creation triggered pressure waves that rippled through this plasma fluid. These were physical sound waves, baryon acoustic oscillations, or BAO rippling through the infant cosmos like a bell struck in the first moments of creation. These sound waves compressed matter into dense shells and rarefied it into troughs traveling outward at nearly 60% the speed of light. They were the heartbeat of the early universe. But then a sudden phase shift occurred. The universe expanded and cooled enough for protons to capture electrons, forming the first neutral hydrogen atoms. The plasma fog cleared and the light broke free. This is the cosmic microwave background we see today. Crucially, when the plasma turned to neutral gas, the pressure that sustained the sound waves vanished. The music stopped. The waves froze in place instantly. The density peaks of these frozen waves became the seeds of galaxies, growing over billions of years into the filaments and walls of the cosmic web. The troughs of the waves, the regions where the sound had thinned out the matter, became the voids. The local void is not a random accident of chaotic drift. It is a fossil. It is the silent gap between the notes of a primordial song preserved for 13 billion years. Its immense size, roughly 150 to 230 million light-years, corresponds to the standard ruler, defined by the physics of those ancient acoustic waves. We are living in the acoustic shadow of the Big Bang. The emptiness that is currently repelling us was carved by the physics of the universe's first breath. We are surfing on the edge of a frozen ripple in space-time. But this acoustic blueprint suggests something even more profound. If these sound waves dictate the structure of the cosmos, they operate on specific scales. The local void is large, but it fits within the standard model. However, recent observations suggest that the anomaly might be far grander than a simple acoustic trough. What if the local void is just a small pocket inside something much, much larger? If sound waves formed voids, could they have formed something bigger? If the local void is a distinct feature on our map, recent evidence suggests it might be just a small ripple inside a much larger wave. This brings us to the most radical hypothesis in modern astrophysics, one that challenges the fundamental assumption that we live in a typical region of the universe. For decades, cosmologists have adhered to the Copernican principle, the idea that Earth is not special and our location is a fair sample of the universe at large. But a persistent crisis in physics suggests this might be wrong. It is called the Hubble Tension. When we measure the expansion of the universe using the cosmic microwave background, we get a value of about 67 kilometers per second per megaparsec. That background glow is the oldest light we can see, the afterglow of the early universe itself. But when we measure it using local stars and supernovae in our own neighborhood, we get a significantly faster value, about 73. The two numbers do not match. The ruler of the universe is broken, and no amount of recalibration has fixed it. In 2013, astronomers Keenan, Barger, and Cowie proposed a solution that is as elegant as it is unsettling, the KBC Void hypothesis. Their model suggests that the local void we identified in 1987 is merely a substructure. They argue that our entire galaxy, along with the local group and Laniakea, sits inside a colossal supervoid spanning nearly 2 billion light-years in diameter. If true, this KBC void would be the largest structure ever observed. And crucially, it explains the broken ruler. Imagine water flowing out of a basin into a surrounding ocean. The water inside the basin flows faster as it rushes toward the rim. Similarly, if we are living inside a region of underdensity matter, naturally flows outward toward the higher density regions, forming the walls of the void. We are riding this gravitational outflow. This extra velocity mimics a faster expansion rate. To us looking out from the inside, it appears the universe is expanding at 73 kilometer-sets, but we are merely seeing the local current of our void distinct from the calmer ocean of the cosmic average. This leads to a profound realization: we are living in a fishbowl. Our view of the cosmos is distorted by the geometry of the empty space surrounding us. The effect of repulsion driving us at 630 km/s is not just a local anomaly. It is a symptom of a grander architecture. We are trapped in a bubble of emptiness so vast that it skews our understanding of the laws of physics themselves. We are building models of the ocean based on the currents of a drain. If our measurements are distorted today, what happens when the sky itself begins to disappear? The distortion of our present is nothing compared to the blindness of our future. The forces driving the local void gravity, clearing the center, and dark energy stretching the space are not static. They are accelerating. We are entering an era of cosmic isolation that will fundamentally rewrite the sky. As dark energy continues to dominate, the expansion of space between galaxy clusters will accelerate. Eventually, it will surpass the speed of light. This does not violate relativity, as space itself has no speed limit, but it creates a hard boundary, the cosmic event horizon. Any light emitted by galaxies beyond this horizon will never reach us. They will become causally disconnected from our reality. In roughly 100 billion years, the local group will have merged into a single giant elliptical galaxy, Milkomeda, but it will be a lonely giant. As the KBC Void continues to expand alongside the accelerating expansion of the universe, every major galaxy cluster will slip beyond our cosmic horizon, Virgo Coma, the great attractor. One by one, they will fade into silence. They will fade from view, redshifting until their light is stretched into radio waves and finally into silence. This leads to the concept of knowledge extinction. Imagine a civilization arising in Milkomeda 150 billion years from now. Let's call their observer the last astronomer. They will possess telescopes far more powerful than the James Webb. They will map every star in their galaxy with perfect precision. But when they look outward into the deep cosmos, they will see nothing. The evidence of the Big Bang, the cosmic microwave background, will have redshifted to a wavelength larger than the size of the visible universe. It will be undetectable. The distant galaxies that allow us to trace the expansion of the universe will be gone. Based on all available empirical data, the last astronomer will conclude that the universe is static eternal and consists of only one island of stars surrounded by an endless empty void. They will construct a model of physics that perfectly fits their observations, yet is completely wrong. They will have no way of knowing that the universe began in a hot Big Bang. They will have no way of knowing that other galaxies ever existed. The physical evidence of our origins is not permanent. It is evaporating. We are living in a temporary window of clarity. We are trapped in a void that pushes us around, yes, but we are also lucky enough to live in the only era where the void is not yet absolute. We can still see the walls of our prison. The civilizations of the deep future will not even know they are trapped. They will mistake their solitary cell for the entirety of existence. The tragedy of the future reveals the miracle of the present. So we return to the sensation of falling. We are still moving at 630 kilometers per second. We are still caught in the gravitational riptide, pushed by the emptiness of the local void and pulled by the titan of Shapley. The physics hasn't changed. We are still prisoners of the cosmic flow. But the meaning of that imprisonment has shifted. For decades we looked at the void and felt small. We looked at the accelerating expansion and felt doomed. But the terrifying timeline of the future reveals the profound miracle of the present. We are not just random observers floating in a random epoch. We are the privileged few. Cosmologists call this the temporal anthropic principle. We live in a specific fleeting window of cosmic history, a golden era. We exist after the universe has cooled enough to form stars and galaxies, but before dark energy has stretched them beyond the horizon. We live in the only time where the universe is readable. The cosmic microwave background still glows in our radio telescopes, whispering the secrets of the Big Bang. The distant galaxies are still visible, allowing us to map the expansion. The voids are still defined enough to be measured, but not yet large enough to isolate us completely. The clues are all here, laid out like a puzzle, waiting to be solved. If humanity had evolved 10 billion years earlier, the universe would have been too hot and chaotic for life. If we had evolved 10 trillion years later, the sky would be a blank slate devoid of history. We are the only generation of observers who will ever see the cosmos in its full glory. This realization transforms our vertigo into responsibility. We are not merely passengers on a runaway galaxy. We are the guardians of memory. We are the species that looked up from the edge of the abyss and wrote down the history of the universe before it could be erased. The theories we build today, the maps we draw of Laniakea and the local void, are the only legacy that can survive the coming darkness. Knowledge is temporary, understanding is borrowed, but this moment belongs to us. So tonight, when you look up at the stars, do not feel insignificant. Feel the weight of the privilege. You are seeing a sky that future civilizations will never know. You are witnessing a universe that is still connected, still vibrant, and still speaking to us. The local void is pushing us away, yes, and the darkness is growing. But for this brief shining moment in deep time, we are awake, we are watching, and we know exactly where we are. The fall continues, the velocity holds, but now, at least we are falling with our eyes wide open.